Good evening, everyone. Good evening, everyone. Can I get your attention, please? Good evening. Good evening, and welcome back to the Marion Minor Cook Athenaeum. My name is Jacob Smagula. I'm one of the 4 Ath Fellows for this year. As technology becomes even more deeply embedded in our everyday lives, it shapes the way we express ourselves creatively and make sense of the world around us. The intersection of art and technology has given rise to new forms of creative expression, and few are exploring this space as profoundly as tonight's speaker, Memo Akten. As a multidisciplinary artist, musician, and researcher, Dr. Akten works at the cutting edge of computational art using artificial intelligence and machine learning to explore the complexities of human-machine interactions. His work pushes the boundaries of artistic expression using intelligent systems to facilitate collaboration between humans and machines, while also probing deeper conceptual questions about perception, meaning, and the nature of reality. In his talk tonight, Dr. Akten will take us through the conceptual motivations behind his recent works, with a focus on AI, embodied interaction, and mixed reality. His explorations are not only practical, developing real-time interactive systems for artistic creation, but also profoundly philosophical, investigating how we project meaning on randomness and noise, and how technology collides with nature, ethics, and tradition. His work forces us to reflect on the broader implications of our increasingly intertwined relationship with technology, particularly in the context of today's social and political divisions, moral uncertainties, and technological dependencies. Dr. Akten is currently an assistant professor of computational art at the University of California, San Diego, and holds a PhD from Goldsmiths University of London. His innovative approach to art and technology has garnered international recognition, including the prestigious Prix Ars Electronica Golden Nika Award. His works, spanning moving images, sounds, installation, and performances, have been widely exhibited across the globe, and he remains a leading figure in how exploration of artificial intelligence and big data can be used to reflect the human condition. Tonight's presentation is co-sponsored by the Gould Center for Humanistic Studies here at CMC. As always, we ask that you please silence your cell phones and direct your attention to tonight's speaker. Without further ado, please join me in welcoming Memo Akten.
Hi, everyone. Thank you for being here. Thank you so much for having me. And thank you to the Gould Center for, again, inviting me. Would it be possible to dim the lights by any chance? Particularly on this side. I stand before you today, a collection of trillions of cells, more than half of which are not even genetically human, but other microorganisms. And somehow, through their interactions, I emerge. To me, it feels like I am a single self, but I know that I am in fact a network. And all intelligence is collective and cooperative. I wasn't sure what kind of talk to give today. Usually when I give artist talks, I will pick a project or two, a recent project, and dig really deep into that 1 or 2 projects. But today I thought I won't do that. It might be more interesting if I go a bit more broad as opposed to deep and try to cover more topics. And I won't even dig too deep into many of my own works, but I'll talk about some more general themes because I thought that might be more interesting. But before I do that, I will give a short overview of what I've been doing for the last couple of decades. As an artist. So primarily, I am an artist, a practicing artist. And I realized almost 10 years ago that all of my work was about waves or God, and that somehow quantum mechanics unified the two. And I look back at what did I mean when I tweeted that, and I think with the term waves, I think I was referring to the patterns in nature which we humans have managed to recognize, to deconstruct and formalize into theories and equations that we somehow find beautiful or elegant. And I think with the term God, I was referring to those mysterious aspects of nature which we have yet to understand, and the lengths that we go to, the stories we tell in our attempts to make sense of them. And I think with the term quantum mechanics, I was referring to the fringes of human knowledge, which we empirically know to be accurate and can understand through the abstract language of mathematics, but we're not yet able to really comprehend on a broader or deeper level. With this backdrop, I work and investigate the tensions between technology, ecology, science, and spirituality. I draw connections between intelligence in nature, intelligence in machines, perception, consciousness, neuroscience, biology, physics, spirituality, ritual, and religion. I'm inspired by nature, or rather the nature of nature, the fundamental forces and underlying processes that shape everything that happens around and inside us. When I look at a flower, I see the nuclear fusion in the heart of the sun, the photons scattering in the atmosphere to create a crimson sky, the photosynthesis that fuels life on Earth, the fluid dynamics driving the wind and the waves crashing onto the shore, and the complex ecosystems they cultivate via a symbiotic spread of seeds. I study these hidden processes that shape our world, and I develop systems that abstract behavior. I'm fascinated by our capacity to dig deeper and discover and learn more about the poetry of nature. I write code, that's my craft, so to speak. I write code to create speculative simulations and data dramatizations. I write code to create moving images, experimental animations, sounds, to control lights, lasers, robots. I collaborate with dancers, I collaborate with machines, I build interactive systems exploring meaningful human control, visual instruments that augment our capacity for creative expression, immersive environments that respond to human presence, computational systems that allow and foster expressive human-machine interaction. I work with emerging technologies, thinking of these technologies as extensions of our body, as extensions of our mind, thinking about their impact on us as individuals, how we behave and express ourselves, and ultimately their impact on culture, ethics, law, tradition, ritual, and religion. I do think about ritual and religion a lot, not necessarily the old, well-established traditional rituals or religions, but rather their new, evolved incarnations, new rituals, new spiritual frameworks, new forms of worship, and the values enmeshed with the technologies that we're creating. What I'm really fascinated by is we, who are biologically identical to what we were 200,000 years ago, how do we cope and adapt throughout the crazy technological developments that we've lived through? I think of rituals as algorithms for the body and mind that transform our mental and emotional state to otherwise unattainable modes of being. And this is why in a lot of my work, I'm trying to capture and convey these sensations that we might relate to spiritual or even religious experiences. I enjoy treading the lines between comfortable and uncomfortable, and I embrace the contradictory complexities of our technoculture. So I try to advance critical perspectives on emerging technologies and social power dynamics, but at the same time, I also strive to create meditative and introspective environments that nurture a sense of wonderment or connection to the planet, connection to the cosmos, connection to each other and all living beings. Finally, I think a lot about the mind, the human mind, non-human minds, biological minds, synthetic minds, distributed minds. I think a lot about intelligence in humans, in nature, in machines. I'm really interested in the technologies and the politics of the technologies and where artificial intelligence as a concept came from and how the technologies have manifested themselves today in our lives and the social and cultural implications of the path that they're on. But I am equally fascinated by a more speculative metaphysics of AI as reflections of ourselves, as reflections on how we perceive the world and how we make meaning, as a computational lens on trying to understand ourselves, the nature of the mind, and perhaps, eventually, even consciousness. So, I'm just going to mute this. With that out of the way, I want to jump back to the 1770s. Has anyone seen this clip or anything like it? Okay, there's one hand. There's a few. So this is an automaton from the 1770s called The Writer by a Swiss clockmaker, Pierre-Jacques Gros. And it's a really, really remarkable machine. It's made up of over 6,000 parts, 6,000 minute cogs and pulleys and levers and cams that are all inside this little boy, this little machine. So it's all internal. It even gets its energy internally. You wind it up, and the potential energy of a spring winds it up. And what it does is it can write actual ink. And it's even programmable in that through, the video will show shortly, through playing with the levers or the wheels on its back, you can tell it what to write. And it comes and it draws. Here it's showing some of the interior. The eyes look around, the head turns, the hand draws perfect calligraphy, and then when it's low on ink, the hand goes over, dips the pen into an ink pot, and comes back and carries on drawing. And it's really, really magnificent. And this is, three centuries old. This is a programmable computer. It's not a general purpose programmable computer in that you can't program it to run Excel or play Fortnite, but it's programmable in that you can tell it what you want it to write. So that's the first thing I wanted to mention. Another interesting thing is this was built with the goal of trying to understand how to recreate handwriting with the thought that writing is an essentially human thing to do. And in a way, writing and language is so linked to cognition. And of course, we look at this and we probably don't even question that there's no cognition happening in this. This is just cogs and levers that are just turning and doing exactly what it's supposed to do. So I don't want to go out on a limb, but does anyone here think that this machine is thinking? Just show of hands. Nevertheless, this is a really, really incredible machine that I wanted to show. So this was 1770s, a programmable computer. Jumping forward to the next century, the 1800s, this is Charles Babbage, the analytical engine. So Babbage was another one of the key figures in the history of computing, which I'm not going to do a very in-depth history here. The analytical engine is quite an important machine because it's thought of as the first general purpose programmable computer, in that here is a computer that can potentially do anything. You can program it to do anything. It wasn't built because Babbage would get into fights a lot, and he just couldn't get funding. But it was a design on paper, and we know a lot about this mainly through his collaborator, Lady Ada Lovelace, who found out about this and started corresponding with Babbage. And she her notes on this are very, very famous. In 1843, she published what we know as Lovelace's notes. And in this publication, there's really, really incredible amounts of foresight. For example, she wrote, "The analytical engine weaves algebraic patterns just as the jacquard loom weaves flowers and leaves." And I will get to the jacquard loom later, actually. She wrote this in 1843, essentially predicting the computational generative art we have today, almost 2 centuries later. But one of her biggest insights was that while Babbage was interested in designing this machine that could compute any function, Lovelace thought that we could maybe use these numbers to represent symbols, and we could do symbolic computation, which means we could then, well, she went on to say, the engine might compose elaborate scientific pieces of music of any degree of complexity or extent. So even though we might attribute generative music to Brian Eno in the 70s, Lady Ada Lovelace was talking about it over a century before that. But amongst these notes is a very famous, even infamous quote, controversial statement, where she said, "The analytical engine has no pretensions whatever to originate anything. It can do whatever we know how to order it to perform. It can follow analysis, but it has no power of anticipating any analytical revelations or truths. Its province is to assist us in making available what we are already acquainted with." And for 2 centuries, we have been arguing over this very statement, whether we know it or not. Every decade, with every new technology, with every new generation of students, this question comes up. Yes, but is the machine really being creative? Can it be creative? This was a question that Alan Turing got interested in a century after Lovelace in his seminal 1950 paper, Computing, Machinery and Intelligence. And he refers to this statement as Lady Lovelace's objection. And he starts this essay with the question, can machines think? And again, a century later, we're still debating this question. So he says that in order to be able to originate anything, a machine should be able to surprise people, especially its programmer. And he notes that machines take me by surprise with great frequency. Also, around the turn of the 20th century, the Spanish neuroscientist Santiago Ramón y Cajal's Nobel Prize-winning work had shed light on this neural architecture in our own brains. And inspired by this, many people, including Turing, started proposing computational structures, not really emulating this, but inspired by it. And Turing had also proposed already in 1948 something he called unorganized machines, which was a machine that could learn. Or in other words, a machine that could program itself. And so he goes on to propose in his 1950 paper, instead of trying to produce a program to simulate the adult mind, why not try to produce one which simulates the child's? If this were then subjected to an appropriate course of education, one would obtain the adult brain. And he adds, an important feature of a learning machine is that its teacher will often be very largely ignorant of quite what is going on inside. So an important point here is Lovelace's position was that a machine could not ever originate something new, a new idea. And Turing's position is, given the science and technology of the time, this might be valid. But if you have a machine that can program itself, then this is a different question. So with this now in mind, with the important feature of a learning machine is that its teacher will be largely ignorant of what is happening inside the machine. So this is simultaneously the most interesting and exciting, but also the most terrifying aspect of machine learning. It's exciting because it allows us to build machines that are potentially capable of doing things that we ourselves don't know how to do, like stabilize the plasma inside a tokamak nuclear fusion reactor, potentially bringing us closer to practically limitless renewable energy, or to predict the 3D structure of a protein given its sequence of constituent amino acids, potentially bringing us a step closer to ridding the world of Alzheimer's and leukemia. But of course, this is also absolutely terrifying, not because there's a danger that machines will rise and take over, but because who is building these machines? Why are they building these machines? What are their values? And is it aligned with the well-being of all human and non-human living and non-living beings? So you might have noticed, I don't think I've said AI yet. I don't really like the term AI. AI is, I mean, no one does. AI is a very, very big, very, very amorphous term. Within AI is an academic field of research. It's also a sci-fi concept, but it's an academic field of research. Within AI, we have a field of research called machine learning, which I touched upon. That's what Alan Turing was talking about. Within machine learning, we have a subfield, which we used to call deep learning. Now it's not really spoken about much anymore. So every time you hear AI today, and for the last maybe 10 years, it's really deep learning. Every time you've heard AI in the last 3 years or 4 years, it's transformers, which is an even more very, very specific subset of that. So I'm mostly going to be talking about machine learning and deep learning today. Very, very quickly, I think, oh, no, I haven't said it yet, actually. So typically when we write software, I'm not going to do a lot of maths. This is the extent of it. We write a function. So that writer automaton that I showed at the start, that automaton, that robot is executing a function. The program is the levers and the cogs and the ratio of the diameter of the gears and the levers. That is the program of that automaton. And you can reprogram it by playing with a few levers. So typically, to be able to program something, we need to know how to do it. So someone had to sit down and figure out what ratio of levers, etc., to put into that automaton to write in that way. So you design a function F, give it an input, and it produces an output. With machine learning, we write a learning algorithm. We don't write the function that we want it to execute. We give it examples of how we want it to behave. Or we put it in an environment where it will get a reward signal from the environment, and we say, go and play and figure out. Effectively, we design the behavior of systems through examples of desired behavior and/or reward signals. And this is why we can use machine learning to do things that we ourselves don't know how to do, as long as we can find examples of what we want it to do. And so deep learning, I won't go too deep into it, if you pardon the pun, is machine learning, but with very, very, very big neural networks. And many things which are interesting here, but when you pipe data through a massive neural network like this one, which is, I'd say, pretty big, it's quite literally a journey through multiple dimensions in transformations in space and time. And in the depths of these neural networks is the great unknown. And that's how I first got interested in at least deep neural networks. Here, this is an algorithm I'm using here called Deep Dream, which was very popular in July of 2015. I won't go too deep into it, but I just want to mention a kind of train of thought that I got really interested in. This algorithm was released by Google. It was a kind of accidental discovery by them, and it's a neural network that's been trained to recognize things in images, and when you run it backwards on something that it doesn't know what it is, it tries to make sense of what it's seeing. Or if I try to explain it in a non-anthropomorphic way, we try to maximize certain activations in the neural network to produce images that maximize certain activations. But the key thing I want to get to here is what I realized is this neural network, or in this algorithm, is trying to reconstruct images based on what is coming in that maximize something that it recognizes. And this is what we are doing when we look at these images, because the neural network produces these images, and then we look at it and we might say, oh, there's a fir tree, there's cables, there's flowers, there's trees, there's deer. But actually, there's no deer. That's not deer. That's weird deer-like features that our brains are desperately trying to make sense of this noise that is coming out of the neural network. And I realized this is like a duet between a biological neural network and a silicon neural network in a quest for making meaning. And ultimately, this is what goes into the neural network. It's just pure, random, white noise. It goes on this long journey through multiple dimensions and transformations in space and time, because that's what a deep neural network is. And this is what comes out, a more structured noise with a more particular distribution. And we are machines that yearn structure. This is who we are. It's what we've always done. We look for patterns, and we find them, and we project what we know onto them. This is how we deal with uncertainty and how we connect with each other. We invent rituals, algorithms for the body and mind that transform our mental and emotional state to otherwise unattainable modes of being. We see things not as they are, but as we are. Everything that you see or read or hear, even these sentences that I'm saying right now, you're trying to make sense of by relating to your own past experiences, filtered by your prior beliefs and knowledge. And actually, I have no idea what any of what I'm saying means to any of you. It's impossible for me to see the world through your eyes and feel what you feel without having read everything you've read, seen everything you've seen, and lived everything that you've lived. And this makes empathy and compassion so much harder than we might think, and that makes it all the more valuable and crucial. This is from a series of work called Learning to See that I made in 2017. It's an artificial neural network running real-time on live camera input, trying to reconstruct. And there's a few themes behind this work. On a practical level, it's exploring expressive human-machine interaction. I am very interested in instruments, like musical instruments, the real-time feedback loop between an instrument and a player. So I'm interested in exploring systems that kind of replicate that modality. But there's higher level motivations. So this is a network that has seen nothing but thousands of images of waves or flowers. And now it looks onto the world, onto my desk, my hands, and it tries to make sense of what it's seeing in context of what it's seen before. But it can see only through the filter of what it already knows, just like us, because we too see things not as they are, but as we are. So this exists also as a number of videos, but also in a kind of interactive installation where I have a plinth with a bunch of junk on it, some cables, some rags, and you can spend a few seconds just playing, or if you're like me, you can spend hours meticulously trying to craft your perfect bouquet or shaping your ideal wave. I trained a few models, so this is a custom architecture, custom model. I trained a few different models inspired by some classic elements of nature. Flowers represents earth, ocean is water, of course. There's fire, clouds represents air or wind. And then the fifth element, which is beyond our planet, the cosmos. This neural network I trained on thousands of images from the Hubble Space Telescope. And we might be tempted to think that this network has learned what deep space looks like. But that's not really true. The Hubble Space Telescope doesn't give us these perfect snapshots, photographs as objective visual representations of deep space. Rather, it streams data. numbers. And then those numbers are interpreted by us, humans, by engineers, by scientists, even by artists, who stitch together patches, composite layers, and even add colors. We don't know what deep space looks like. I don't even know if we can fathom those kinds of scales, hundreds of thousands of light years in diameter. So this neural network isn't learning what space looks like. It's learning what we think space should look like, tainted with our assumptions, our biases, and our romantic visions. In fact, the art historian Elizabeth Kessler, in her book, Picturing the Cosmos, Hubble Space Telescope Images and the Astronomical Sublime, discusses the similarity with regards to color, composition, framing, between the Hubble images and the 19th century landscape paintings of the American West during the expansion. The choices made by the artists and scientists interpreting the Hubble data may have been unconscious. I'm not necessarily, and he's also not suggesting that there's bad intention here, but it's deep in their psyche that when deciding how these images get presented to the public, hoping to create a sense of wonder and awe of the vast open spaces, inviting viewers to experience deep space, much like the way 19th century landscape paintings were used to evoke the grandeur of the new world, a new frontier, waiting to be discovered and colonized. And speaking of romantic visions, there is another motivation behind this particular data set and work and why I use the microscope, because I enjoy being reminded that the atoms in my body and in yours and in everything around us were forged in the dying hearts of stars, exploding into supernova billions of years ago, billions of light years away, and spewed across galaxies to come together for a very brief moment in time to momentarily become me and you. We are all connected. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. So the work that I just showed was pretty old. It was from 2017. Times were very different then, in those prehistoric times. And having chatted with a lot of you, well, not a lot, having chatted with some of you prior, very engaging, interesting topics, I imagine a lot of the experience some of you might have with AI is, let's say, if it's been happening in the last couple of years, it's a very specific kind of technology. So things changed in 2021. When I'm working with these things that I was showing, you have to program. There was really no other way. You have to get in there, you have to program. Quite often you had to train your own models, you had to build your own models, collect data sets, etc. Things have changed. Now you type something in a prompt and you get an image. It's way more accessible. There's a lot of controversy, and I'm going to touch upon some of this stuff now. I imagine a lot of you have heard of Midjourney. If not Midjourney, you might have heard of DALL-E, even ChatGPT. As I mentioned, you type something and you get something, an image, out of a huge data set. So these are huge, huge models. These kind of models are not the kind of models that I could train on my home gaming PC that I could 5 years ago. These kind of foundation models require clusters of thousands of computers. They require millions, if not billions of dollars worth of infrastructure to train. I could train a model on maybe 1,000 images 5, 6, 7 years ago. Nowadays, you can train on many, 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 many millions, maybe even billions. Actually, billions. Leon is billion. Billions of images. And there's been a lot of division, as I'm sure a lot of you are familiar with. So what's been happening is we have companies, and we were just discussing this at the dinner table, that get funding. They raise millions, tens of millions, hundreds of millions of funding. Then they scrape the internet for data. They use that to build a product. And then that ups their own valuation 10x, 100x. I think OpenAI is now worth over $1 billion. OpenAI is the company behind ChatGPT. Whereas all the people who created the data that went into producing this value, because that's what's happening, value is being created, but millions of people who worked to create this value are not only not getting anything, they're potentially losing their income stream because they're going to be undercut because Spotify is going to stop giving them the the 2 cents royalties, but it's going to just produce their own music, or the same with visuals. So there's been a lot of anger. And I'd like to talk a little bit about both very dark, but also very positive perspectives. But first, I really want to go back in time again. I mentioned the Jacquard loom. Lady Ada Lovelace mentioned the Jacquard loom. So this is a Jacquard loom from the early 1800s. It's effectively a programmable weaving computer. And the way this works is there are punch cards with holes in it. She'll probably show shortly. Those holes on the punch cards represent an algorithm of how a pattern should be woven. And this machine is actually the precursor to the general purpose computers that followed it. So this is a programmable computer, it weaves. The interesting thing that I wanted to mention, and the reason why I brought this up, is because automation started happening in the late 1700s. Well, it's been happening a lot, but in the late 1700s, early 1800s, there was a big boom in automation. The Jacquard loom is one of these. And prior to this, weaving was an artisanal activity. And there, I'll just go to the next slide to show this. So this is like a factory that's mass producing weavings. In the UK, there is a term called Luddite, which is a very... Is anyone here familiar with the term Luddite? Okay, most people, or at least some people. In England, it's very common. So Luddite is typically used as a derogatory term for someone who is afraid of technology. Someone is maybe not very smart and just isn't with the times. Like, oh, I don't know how to post this thing on Facebook. Oh, you're such a Luddite. Is a kind of use. Or I don't know how to do this thing with my car. There's this button. Luddite. Where Luddites came from is the Luddites were a movement in the early 1800s who were opposing this automation. They were artisans, they were weavers. But here's the interesting thing. These machines started coming into factories. These machines took the knowledge of these artisanal weavers, the centuries of knowledge of how to weave and what kind of patterns to do and how things work with weaving. It took that knowledge, encoded it into a card, and the weavers were no longer necessary. There is a version of this story, of this world, that could have ended up like the factory. Let's say a factory needed 10 weavers to produce a certain amount of tapestries to meet the demands. When these machines came in, it doesn't need 10 workers anymore. It needs 1 worker. So then a version of this could be, well, maybe only they work 1 every 10 days, but they split the profits. But of course, that's not what happened. What happens is the weavers would get laid off, and an unskilled laborer would come in to operate the machines. So the value created by the weaver's knowledge, which was encoded into the card, all of that value went into the factory owners, and none of it went back to the weavers. So the weavers were very angry, and there were very violent protests. Factories were being burnt, there was lots of shooting, thousands of people died. The government, this is happening in the UK, the government came down really, really strong and made it illegal to protest, such that factory owners were allowed to shoot protesters, well, which they did. So apart from the shooting, there's a lot of parallels in AI art. And I just use the word AI art, which I hate, so forgive me. But this is what's interesting, is that the value created by all the people is not, the artist is not going back to them. So I just used the word AI art by accident. I don't like that term because I don't know what it means and what it means to you, more importantly. If I use the word AI art, it means something to you because there's so much baggage with that word. I don't know what it means to you. I make art with AI, but I don't use Midjourney or DALL-E or anything like that. I wanted to start some closing thoughts. AI as a field, as an academic discipline with the name AI has been around since 1955. As a topic, as a concept, arguably it goes back, thousands of years. But it was coined in a workshop proposal in 1955 by John McCarthy, Marvin Minsky, a few folks. I'm not going to go deep into history, but I just want to mention some patterns that I just want you to be aware of. In 1955, this proposal for a workshop wanted to do there's a lot of text, I'll just highlight some key things, a 2-month, 10-man study. Every aspect of learning or any other feature of intelligence. Make machines use language, form abstractions, concepts, solve problems reserved for humans, and improve them. They believed a significant advance could be made in 2 months. They were very wrong. Ray Solomonoff was one of these scientists. He passed away, actually more than a few years ago, sadly. He wrote, they were hoping that they would produce some results, but the group of scientists were motley, and so were their proposals. Everyone had a different idea, a big ego, and much enthusiasm. In other words, people couldn't agree on what to do. And this is a very, very, very strong theme that's recurring today. Like if you follow some AI folks on Twitter, like I can't even look anymore. It's almost like kindergarten level arguing between different camps of how we should do AI. But I also want to draw attention to the optimism and the hype. Herbert Simon, who won a Nobel Prize, and a Turing Award, the highest award in computing, and Alan Newell. Both of these people, very, very influential in AI. They developed some of the earliest theorem provers and general problem solvers. But they believed in 1958 that within 10 years, a computer would be a world chess champion and would prove a new and important new mathematical theorem. So by 1968, they believed that would happen. Didn't happen. In 1958, New York Times wrote about Frank Rosenblatt, who is really the pioneer of the neural networks that we use today, revealed the embryo of an electronic computer that it expects will be able to walk, talk, see, write, reproduce, and be conscious of its existence. Again, hasn't happened yet. 1960, Herbert Simon said machines would be capable within 20 years of doing any work that a man can do. So by 1970, Nobel Prize laureate, Turing Award winner, made this claim. 1963, Stanford AI Lab was founded, very, very influential, very big, important lab, building a fully intelligent machine within a decade. Marvin Minsky founded MIT's AI Lab within a generation, or actually he said a few years later, within 3 to 8 years, the general intelligence of an average human being, so within the 70s. So I say all this, when you hear Elon Musk saying that he'll have a fleet of self-driving cars by the end of the year, and he's been saying this for 10 years, he's just following this pattern. easy things are hard, it turns out. Marvin Minsky, John McKenna, I mean, these people are geniuses, so don't get me wrong. Like, I'm very grateful for the work that they did, but I just want to show how interesting it is that how even such smart people can get such fundamental things in retrospect so wrong. Another cycle, I'm not going to go into details here, because of that optimism and hype, there has been intense periods of crazy funding. FOMO is real. Once someone starts funding, everyone else has to fund. You don't want to lose the AI race. DARPA, the military, has funded a lot. These crazy promises. I mean, who wouldn't want to have a machine that's conscious and reproduce itself if you're the military, right? So then they realize 10 years later that it's all not going to work out. So then we go into a winter and there's no more funding. And then a new technology comes out and the hype cycle begins. So this has happened 3 or 4 times. Spring, winter, spring, winter, spring, winter. We've just had a long winter throughout the 90s and early 2000s, and we've entered a new spring for the last 10 years. Many people believe this time it's here to stay. I mean, we'll see what happens. With regards to art and AI, I'd like to end, I've got a few more slides actually. How much time do I have? Am I over? Okay. So Doug Hofstadter is a cognitive scientist. This book was hugely influential for many people, including myself. This is from '79. He has a later book, I Am a Strange Loop, which actually I find more influential for me. It's on consciousness and feedback loops. In this book, Hofstadter says a lot of very interesting things, which he has gone back on. He said that he didn't think a computer could ever beat a person in chess, could beat a human in chess. And it turns out chess is a really easy problem to solve for a computer. Recognizing whether an image is a cat, that was a difficult problem. But he also says, there's a lot of text here, he basically says that a computer might be able to imitate making music, but it can never actually compose music because it doesn't have emotions, it doesn't feel. And this has been his general perspective. And already in the 80s and 90s, there were lots of generative music algorithms that don't use deep learning, but are still nevertheless very effective. And Hofstadter himself at a lecture did a test where he played Chopin, actual Chopin, and a piece composed by this algorithm in the 90s and asked which one is a computer, which one is a human. And the majority of the audience got it wrong. They thought Chopin was a machine, the real Chopin was composed by a machine, and what the machine composed they thought was Chopin. And this really traumatized Hofstadter. In fact, I just watched an interview with him a few days ago, an interview that he recorded earlier this year, where again he uses the term traumatized. And I don't have it on the slide, but I just wrote it down quickly because I just found it. My whole intellectual edifice, my system of beliefs, it's a very traumatic experience when some of your most core beliefs about the world start collapsing. And what he said with regards to this EMI, the experiments in musical intelligence, what he said with regards to that is this. So Hofstadter is a computationalist. He does believe that the mind, the brain is a computer. He doesn't believe in a supernatural spirit. So he has always believed that theoretically, a computer should be able to do anything a human can do. But he didn't think it was practically possible. And the trauma that he's talking about is, it turns out we might not be that complicated. It might be that in his lifetime, this will happen. He just never thought that it would. And this trauma, even before Hofstadter called it trauma, I recognized this. And I find it very morbidly fascinating because centuries ago we had discovered what was exhilarating for some people, but too painful for many others to accept, that we are not the only planet in existence. We later realized that we are not the only solar system. We are not the only galaxy, and many of our smartest today are questioning whether we are even the only universe in existence. Every one of these discoveries brought with it a realization that was exciting, liberating, and humbling for some, but very painful for others. A decentering of human exceptionalism, a Copernican turn, a Copernican trauma that forced humanity into revisiting our perceptions on how we relate to the world, the cosmos, and all its human and non-human inhabitants. And with the rise of AI, we are now facing these age-old questions that we have pondered over for thousands of years through this new lens of computation. And now we face the ultimate Copernican trauma, the final decentering of human exceptionalism, where this time the arena of realization is not situated outside of us, but within. It's not regarding where we are in relation to the world, but who we are. And we are now faced with the reality that we might not be the sole keepers of what we might consider to be intelligence or creativity. Much simpler with the gift of hindsight, we can now see how the dangerous dichotomy of man versus nature, and I use gendered language here deliberately, has allowed man to justify his attempted subjugation and dominion of nature. And today we are experiencing the devastating consequences of this manufactured divide as we face mass extinctions, global warming, and ecological collapse. I stand before you today a collection of trillions of cells, more than half of which are not even genetically human, but other microorganisms. Trillions of incredibly complex, intelligent little machines work together to keep me alive so that I can keep them alive. And somehow, through their interactions, I emerge. And to me, it feels like I am a single unitary entity with clear boundaries that I call my skin. But intellectually, I know that I am in fact a network. I am a network of cells and organisms, both within my skin and also reaching well beyond. I am a network of atoms that I borrow and exchange with my environment, with other living and non-living things. The atoms that I eat and drink, the atoms that I inhale and exhale. But I am much more than that. I am also the result of every conversation I've ever had, every book I've read, every film I've watched, every interaction I've ever had with every being, human or non-human. And every being that I've ever interacted with is also the result of every being they've ever interacted with. And from all of this, I emerge. In 1968, astronauts saw something extraordinary for the first time. Their entire body, a radiant living planet, hurtling through the void. I stand before you today, nourished by ancient oceans, warmed by ancient starlight. My body, a site of journeys and transits, portals and interfaces, a chimera. I am a body. I am also a multitude of smaller living bodies. I am a body, and I am also part of a greater living body. Intellectually, I know I'm part of a living planet, but how can I feel this? Today, our planet is sending us warnings. As the waves intensify, they throw our chemicals back into the air. As the waters warm and acidify, they threaten life as we know it. The excess energy in the atmosphere fuels ever stronger storms. In my own body, I feel the severance from planetary time, from planetary body, from planetary memory. I am in superposition. My body is an animal alive in the present, but my mind is trapped in the future and the past. What if we shed our skin and vibrate in collective effervescence? Thank you for your time, and that is the end of my presentation.
All right, thank you so much again for your talk. And now it is time for the Q&A section of the talk. So if you would like to come ask a question, feel free to line up behind me or Brian on the other side. When you come up to ask a question, make sure that you say your first and last name, what you're studying, and what school you attend. And keep your questions brief and no follow-up if possible. Thank you.
I guess I'm up first.
Hey, hi.
Hi. Thank you for coming. My name is Amy Johnston. I'm a senior at Pitzer. I'm studying computational neuroscience and philosophy, so I also spend a lot of time thinking about waves and God.
Okay.
And I'm curious if you would say that you would subscribe to more of a reductionist point of view or a dualist view of the mind, and because it sort of seems like you do subscribe to a more reductionist view, how do you reconcile that with your identity as an artist and the value of your work?
That's a very good question. So if the question is with regards to being a reductionist, specifically with regards to the mind, I would say I'm not fully committed. I think, well, I'll put it this way, the brain is a computer. Like, it computes. I don't think that is really shouldn't be that much of a question. We know even a basic neural network with a recurrent loop can compute any function, any program even. So there's no doubt that the brain is a computer. I am very eagerly following Penrose and Hameroff's auteur, the idea that there might be quantum phenomena that is linked to cognition. I'm not betting on it, but I think it's interesting to follow. So I'm working under the, let's say, working hypothesis that the brain and the body is fully computational. With regards to being a reductionist, I will say this, it's very interesting you brought that up, because the last piece that I showed is very much about embracing a superposition of epistemologies with regards to being a reductionist, but also being very holistic in how we approach things. And the example I like to talk about is, for example, soil and growing things. And we might say, what are the best conditions to grow tomatoes? And I'm not by no means an expert on this, but there's one way of thinking about it which says there's a spirit of the soil, and this certain spirit that goes with growing tomatoes, which is a kind of way of thinking that even my own training would look down upon completely. And then there's the way of thinking of, okay, we need 37% moisture, we need potassium, we need nitrogen, a much more reductionist way. The reductionist way of thinking has allowed things like this to happen. I'm speaking into a microphone, it works amazingly well. But it's also allowed us to detach ourselves and see things as interchangeable without really having a full understanding of the long-term impacts. And that's why I believe we are where we are today. And I mean, there's countless examples of people trying to optimize yields of timber or crop and it backfiring because we don't really understand the complexities of the ecosystems. So I think having a superposition of epistemologies, and I use superposition because I think that word captures the difficulty in that it's very difficult for us to comprehend a thing being in two places at once. And in a similar way, having a reductionist and a holistic, even spiritual approach might seem incompatible, but I think it's essential to embrace it.
Thank you.
Thank you for the question.
Hi, my name is Nico, and I'm a sophomore at CMC. I majored in media studies with a minor in computer science. And I wanted to zoom in on something you mentioned during your talk, which is the example of the jacquard loom and the artisans. So I feel like that is an even better example of the parallels today better than even the example I brought up to you, which is photography and painting. And I was wondering, in that situation, even with the attempts of the Luddite movement to kind of stop that technology, how do you think that today we can maybe approach that situation differently, where we're facing very similar situations of centuries of artwork being encoded into something that can now produce it in a second? So I'm wondering, just like, what are your thoughts on what could be done differently this time?
That's a good question, and I wish I had a roadmap, but ultimately the answer to that question is also the answer to the question, how do we fix the world? How do we fix the economic disparities? How do we, the underlying issues are just so much bigger than AI. It's the way we've structured our whole society and economic system. I will say that my personal approach as an artist is, I'm not a policymaker. I've sat at a table with policymakers, and policymakers have a very different approach. It's a lot more real world. My approach has generally been trying to talk about values. What are the values that I cherish, that I want to live in a world with? And I think it was Ursula Le Guin who said in a speech, oh God, I need to remember this. She said something like, it's up to the artists, particularly literary artists in her case, obviously she was talking about, to imagine new worlds. I know it seems unimaginable, but so did the divine rights of kings, to think of a different way of being, but so did the divine rights of kings. It felt so inescapable. And so my approach is to be within a community of people who try to talk about what are the values we want to see. And an example I will give, they don't fund me, but like Runway is a platform that does AI tools, is founded by an artist. So it is an artist first, of course they care about artists, because it was started out as an open source tool for themselves, and then it grew. So it depends who's building tools, why they're building tools, and as a society, who do we value? Who do we hold up as heroes? What kind of characteristics in people and leaders do we see as good qualities, and which ones do we not see as good qualities? So that's, I guess, a very abstract answer, but yeah, that's where I'm coming from. I hope that answers your question a bit.
Thank you.
Hi, my name is Marilyn. I'm a sophomore majoring in economics and engineering. Personally, I'm also very interested in art, and particularly this intersection between art and technology. So I just want to thank you so much for this talk, and it's been very inspiring. And I guess my question is, I want to know a little bit more about your personal journey. How did you first find this intersection? What was your technical background, and what advice would you give to people who are also trying to explore this area?
Okay, a great question. So, just very quickly, my undergrad, I'm a civil engineer. I grew up in Turkey in the 80s, and I didn't want to be a civil engineer, but grew up in Turkey. People were always in buildings, is what I was told. I come from a family of civil engineers, so I studied that, which in retrospect was good because I learned, maths and physics and all that. But really, the way I got into this is I started coding at the age of 10. I was very fortunate. In the 80s, my parents got a computer. They thought it was going to be big, and I guess they were right. So I learned how to program, but my interest in programming was I actually wanted to be a filmmaker. And it was such a far-fetched dream that it wasn't even a dream. It was one of those dreams that I was too afraid to even dream it, because a kid in Turkey in the 80s, there's no internet, I don't even know anyone with a camera. No, that's like I might as well want to be an astronaut. So I would code, I taught myself to code to make things, and it just grew with that. Now, I'm a professor at UCSD, and I do teach art students, but also CS and maths majors. I quite often, after a class, get a student from CS come and say, "Oh, you've completely changed my world, I want to be an artist." And I'm like, I don't want that responsibility. You've got a potentially lucrative career ahead of you. Being an artist, is tough. But I will say this, like, for many, many years, well, all artists live off side gigs, for quite a while at least. Many artists, work waiters, bars, or do all kinds of things. Because of my technical skills, my side gigs were like doing a database for a bank, or, there were things for me to do. Now, I think it's, as a creative technologist, so being an artist is one thing, but being a creative technologist is different, particularly in LA. So there are a lot of work for people who understand technology, but also understand creative sector. And that's different to being an artist in galleries and things like that. So there is a lot of work in that field, if you can bridge the two.
Thank you.
Hello, my name is AJ. I'm a sophomore at CMC studying philosophy, math, and computer science. And I'm wondering how you feel about the recent trend of AI research being developed mostly by large companies like Google. I think, for example, like the initial paper on transformers was developed by Google, and there's been a lot of other advancements by these large companies. How do you think that affects our overall knowledge of AI? And do you think that's better than research being done primarily by academics?
Yeah, that's a great question. Short answer is it's terrible. Like, even 5 years ago, a lot of stuff was coming out of academia. Also, a lot of things were open source because it's coming out of academia, PhD students, etc. And it's shifted to purely industry. There was a very interesting article. I referenced AlphaFold, which is the AI software that DeepMind created. DeepMind is owned by Google, and it's a thing that you give it an amino acid chain and it predicts a 3D structure. This has been an unsolvable problem ever since DNA was discovered, and it's a really, really, really big deal. And I personally know many people who have been working on this problem. It's not my domain, so I can't comment on the specifics, but I will say this. DeepMind basically came out, AlphaFold 1, AlphaFold 2, just by many, like a huge margin, basically pretty much solved at least the very narrow problem of single strain. So it really did a huge thing. And I read a very, very long article by an academic who had dedicated his life on solving this problem. And he said he's both very, very angry, because one thing is, DeepMind did this. They released the paper, but it didn't have enough information to replicate it. They didn't release the data set. Basically, it's been solved, but it's in Google's thing. Now I think they've released it. But so what this academic wrote is, I look at the way Google solved this problem, and academia couldn't have solved this. The way academia works, research in academia, this problem, Google DeepMind worked on this, I don't know, for 10, 15 years, put X amount of money in it, and this team did nothing but that. And so this academic was talking about how he works and how he's applying for grants. And then he gets a PhD student who works for 5 years and then goes, and then he gets another PhD student for another 5. And just the way that system is incompatible with a project as large as AlphaFold. You know, many academics said, I don't consider this problem solved until I can run it on my computer. Like, what good is it to me if it's only on Google servers? So this is a big issue, and especially when we consider the motivations of companies are to maximize profit. Like, it's literally the law that a CEO has to maximize profit for the shareholders. That's the CEO's job. So it's far from ideal, definitely.
Thank you.
All right, with that, can everyone join me in thanking Memo Akten for the wonderful talk?
Thank you all.